The U.S. Department of Energy's Albuquerque Operations Office, Los Alamos National Laboratory, Lawrence Livermore National Laboratory, Sandia National Laboratories, the component production plants of the nuclear weapons complex, all interact to design and produce the American nuclear deterrent. Albuquerque Operations has overall responsibility for production oversight and delivery of these weapons to the Department of Defense. This is Mound, an integrated research, development, and production facility for the development, manufacturing, and surveillance of explosive components. In addition, Mound has a number of other programs devoted to research, development, and production. These include a variety of isotopes with a major emphasis on tritium, which is radioactive hydrogen. Such is the complexity of that work and the attendant concerns for quality and productivity that Mound employs a highly trained scientific staff and utilizes sophisticated technologies. To make a product with a perfectly functional 25-year useful life is no simple matter. Frontier technology is the key to performance, therefore, and we would like to share some of it with you today. Mound began working with ceramics technology in the late 50s as a part of its heat source program. Back then, no one would have guessed that it would have been such an important technology for weapons programs today. Take, for example, the MC-3753 actuator that is used in the ground-launched cruise missile and in the B-83 bomb. It will also be used in many future weapon systems. This tight little package is a marvel because of its intricate geometry and demanding performance requirements. And talk about performance. This actuator is 8 times stronger than previous valve actuators, containing dynamic pressures of 150,000 pounds per square inch. It is the wave of the future in glass ceramics. Development efforts focus on cost-effective processes like injection molding and vacuum-assisted molding. These take fewer production steps, produce a stronger component, and keep Mound at the leading edge of ceramics technology, especially where quality is a key requirement. Quality improvements in these products are accomplished by such steps as eliminating moisture from the production process. Moisture in a ceramic furnace can cause bubbles to form in the glass during the cooling process. An innovative solution to this problem is Sahara-like dry rooms for producing ceramics. Their constant temperature is 70 degrees and humidity is less than 5%. They are a first of their kind. Ceramics technology goes far beyond production involving exotic materials. There is also the matter of performance, which requires specialized destructive and non-destructive testing. Mound looks at finished products with everything from lasers to acoustics. Acoustics, for example, is a very specialized way of looking inside materials, a sonic X-ray, if you will, that shows many features other diagnostic techniques can't see. But there are other ways to see, too. Seeing components working in slow motion, for example, using the copper vapor laser as a high-intensity strobe light. A high-speed camera is used to capture the images illuminated by the green laser light, revealing details occurring in thousandths of a second. Surface analysis is another important matter. Using a variety of tools, concerns about material incompatibilities are addressed and resolved before they become production problems. Microelectronics is another tool that supports weapons technology. Looking into the 1990s, Mound sees applications of microsystems to make components perform more precisely for greater quality and reliability. Laser-ignited devices, a new breed of explosive and pyrotechnic components, are being developed with both Sandia National Laboratory, Albuquerque, and the Los Alamos National Laboratory. These devices offer further improvement in weapon safety with the electrical isolation of the explosive material from the firing circuit. Electrical lead wires are replaced by optical fibers, which carry a concentrated beam of laser light a few thousandths of an inch in diameter to the explosive. The high-power laser diode is one of a variety of laser ignition sources Mound is studying. Its small size and weight make it an attractive candidate for pairing with pyrotechnic devices. Other ignition sources include the continuous wave argon ion, carbon dioxide, and neodymium YAG lasers, and the pulsed ND YAG laser. These sources are used to characterize laser ignition properties of materials for the next generation of Mound components. Since the early 1980s, Mound has been building what is now an extensive flexible circuit technology base. And in 1984, actual production of these circuits began. There is now a long-term commitment to this detonator technology. In general terms, flexible circuits are etched, printed metal conductors that are used to transmit electrical signals from one point to another. They are etched from metal-clad films and are the design basis for nearly all of Mound's slapper detonator components. Mound has one of the few state-of-the-art reel-to-reel processing facilities in the United States. Mostly custom-built, it is currently used to manufacture cable detonator assemblies in support of the Peacekeeper MX and the Trident II. It is continually being upgraded, incorporating the latest manufacturing technologies. Here's some hot stuff. It's a thermite reaction that could play an important role in future weapons designs. Thermites are metal powders blended with metal oxides that react to produce heat in an essentially gasless manner. Thus, they are excellent chemical heat sources. Thermites can be molded and formed into a myriad of designs and configurations, and Mound is at the leading edge of thermite technology. For example, a new fabrication technique, plasma forming, has expanded the complexity of shapes into which these useful materials can be formed. And when the future takes shape, thermites will be a useful tool in weapons applications. At Mound, there is a different way of looking at things, at least product-wise. Micro-welding, spin testing, robots with fiber optic eyes, high-speed diagnostics, all in support of the Mound mission. And in production of metal parts, a different way of doing things. It's called flexible machining. From its beginning in 1985, using a borrowed robot and a computer numerically controlled turning center, Mound has developed a capability to design, assemble, and integrate equipment into flexible machining cells, or FMCs. This FMC was built by a team of 5 people, engineers, programmer, and tool makers, and is capable of manufacturing 2 families of parts. One person operates the cell, which contains 3 machine tools and the materials handling robot. The cell does the work of 6 conventional machines, improving productivity by a factor of 6. But more than that, product quality has improved, primarily through the use of the computer numerically controlled multi-axis machine tools. Building on what the team learned on the parts fabrication cell, the flexible machining concepts have recently been applied to the manufacturing process itself. In this case, glass ceramic components. This family of parts is moving from manual machining to flexible machining processes. Benefits include machining times reduced by more than 2/3, tool life extended by a factor of 3, and acceptance rates approaching 100%. The robot, coupled with the CNC machine's repeatability, allows for 80% unattended operation. Finally, the inspection area has also benefited from flexible thinking. Once this computerized measuring machine, or CMM, is programmed to measure a part, the inspection software is stored for future use. Today, these software libraries are taking the place of expensive, delicate, single-use hard gauges. If the designer changes a dimension, a software change has the CMM ready for the new part quickly. The concept of flexibility in parts machining, component manufacturing, and inspection provides a rapid response to changing parts requirements and a competitive advantage in the global marketplace. Kyle, Chaps, Acorn, S-Rock, all expressions of the programmatic capabilities in Tritium Technology at Mound. As the lead site in tritium recovery, Mound has developed a significant capability in tritium handling, containment, and control. This is directly applicable to production programs such as Kyle. At the same time, there is a significant body of technology that surrounds the tritium work itself. In this most modern of tritium handling facilities, it is the computer system that controls processes and production steps, and keeps the records as well. Thus, Mound's tritium operation is a paperless and consequently much more accurate system. The tritium operation is also supported by advanced control and monitoring systems, such as this mass spectrometer, where one individual can instantly monitor over 144 sampling points. Finally, the production itself utilizes another Mound specialty, welding, and its special applications. Calorimetry, the measurement of thermal output, is used for material accountability and product acceptance in nuclear facilities all over the world. Mound is recognized as a center of excellence for calorimetry by the DOE. Calorimeters come in many sizes and provide accurate measurements ranging from microwatts up to hundreds of watts. Calorimeters can be transportable, or they can be permanently installed, both in and out of glove boxes. Automated sample handling and data analysis are features which are often included in the turnkey systems supplied by Mound. Over 145 Mound designed and built calorimeters are currently in use at 10 DOE sites, providing state-of-the-art measurement capabilities. Mound is proud to be a part of the Department of Energy's nuclear weapons complex. Directed by the Albuquerque Operations Office, the design agencies, the production sites, and the assembly plants all work together in a partnership to meet quality, schedule, and cost requirements. While most of Mound's components may be small in size, each employee and subcontractor recognizes the importance of each part's quality and reliability as a large factor in keeping peace.